In this video, we're going to look at finding the slope of a secant line between two x values for a given function f of x. We remember that a secant line is a line that intersects our given function in two places. So what we're going to end up doing with this problem is we're going to construct our secant line so that it intersects our graph at x equals 10 and at x equals negative 3. And in order to find the slope of our secant line, we're going to use the slope formula that we've come to know and love, which we typically call rise over run, but in a more mathematical sense, what we're going to call it is the slope of our secant, and how we're going to find that is f of x1 minus f of x2 over x1 minus x2. This is the change in our y's, this is the change in our x's, so that's why it's typically called rise over run. So we're given x1 and x2. They're given to us in the problem. What we need to do is find f of x1 and f of x2 by evaluating our function at these two given points, and then plugging them into this formula and simplifying the answer down until we find our slope. Since we're dealing with a rational function here, we know that a rational function may not always be continuous everywhere. So what we're going to do, we're going to see what values could possibly pose issues for us in terms of maybe being undefined in this graph or some other type of problem like that. So when we look at a rational function, we know that if our domain is 0, we have a vertical asymptote at that x value. So we know that if the expression 4x plus 4 times negative 1 is 0, we're going to have a vertical asymptote at the value where this expression is true. So let's go ahead and solve that. In order to get rid of this negative, we can go ahead and divide it away, since technically what this is we're multiplying this expression by negative 1. So if we divide everything by negative 1, this all cancels out, and we get 4x plus 4 equals 0, or x equals, if we subtract 4, we get 4x equals negative 4, divide by 4, we get x equals negative 1. So there's a vertical asymptote at x equals negative 1. The reason why this isn't really a concern for us is we're not evaluating anything at x equals negative 1. So we're good there, we don't have to worry about it. But what about a horizontal asymptote? We know that if the degrees of our polynomials here that we have are the same, if we divide the leading coefficients of those polynomials, the answer, or the quotient that we get there, is going to be where our horizontal asymptote is. So what we have is there's a horizontal asymptote at 2 divided by negative 4, or negative 1/2. So what that means for our case here is that if we were to evaluate either 10 or negative 3 in this function, and we get a value of negative 1/2, we're going to find that that's not really something that we can have, and that's an issue, we did something wrong. So let's see if this even poses a problem for us, and let's go ahead and start evaluating our function. So what we're going to do first is let's evaluate f of x1, which is f of 10. That gives us 2 times 10 minus 7 over negative 4 times 10 plus 4. We're going to evaluate all this simultaneously. We get 2 times 10, which is 20, minus 7 is 13, over negative 4 times 10 is 40, plus 4 is 44. So for f of 10, we return a value of negative 13 over 44, not equivalent to negative 1/2, so we're okay. Now let's evaluate f of x sub 2, which in this case we called f of negative 3. We're going to do the same process again, just replacing 10 with negative 3. So we get negative times 4 times negative 3 plus 4. And that's going to be there. Okay, so 2 times negative 3 gives us negative 6, minus 7 is negative 13 again, over 4 times negative 3 is negative 12, plus 4 gives us negative 8, so we get negative 8, which turns out to be negative 13 over 8. And we see that again, this value does not equal negative 1/2, so we're okay. We get two legitimate f of x1 and f of x2 values. So now, without further ado, let's actually calculate our slope. In order to calculate our slope, we're going to use the formula that we referenced earlier. So we have, actually we're going to write it over here where there's a little bit more space to work. So we have m subsecant, which is slope of secant. We typically refer to slope as m. So we have f of x1, which we evaluate to be negative 13 over 44. Then we have f of x2, which is negative 13 over 8. So this is actually going to turn into plus 13 over 8. Because our formula calls for subtraction, we have a negative value. A negative times a negative is a positive, so we have this on the top. And then our bottom is simply going to be 10 plus 3. Because again, we have a negative value, a subtraction in the equation, so we're going to go ahead and have a positive down there. We see very quickly that our denominator becomes 13. This numerator becomes a little bit more hectic to work with. In order to add fractions, we need a common denominator, and we see that 8 doesn't go into 44, so we have to try to find something else. But using some quick math, we see that 44 goes into 88, and 8 goes into 88. In order to get that, we have to multiply, or to get denominators that are 88, we have to multiply 44 by 2 and 8 by 11. So when we multiply those denominators respectively, we also have to do the same thing to our numerators. So what we're going to get is we get this over 88. 2 times negative 13 gives us negative 26. 11 times 13 gives us 143 over 88. So this really becomes 1 fraction over 88. We're going to keep our denominator going. Negative 26 plus 143 works out to be 117. So we have 117 over 88 over 13, and we understand that this is over 1. The reason why that's important is because when we have a fraction divided by a fraction, we're going to do keep, flip, multiply to make it 1 fraction. What keep, flip, multiply actually is multiplying by the reciprocal of the denominator. When we do that, the denominator cancels out to 1, so we're left with 117 times 1 over 88 times 13. But we see that 13 divides into 117 9 times. So what this actually is 9 over 88. So what we get is that the slope of our secant line between x equals 10 and x equals negative 3 works out to be 9 over 88.